Okay, now let's consider there is a block sitting on a surface. So initially there will be its weight acting downwards, and there will be a normal reaction acting vertically upwards, right? Which will balance the downward weight. Now let's say we apply a force in horizontally in the pull the object, and we apply such a force which is equal to the force of limiting friction. That is to say, if we apply a force and the object just starts moving, it apply a force such that the object just starts moving, the maximum value of opposition it offers is offered by the friction, and so that opposition force will be along the tangent, but we have put it here so that it becomes easy for us to see the diagram, draw the diagram. And we have Fs max here, maximum amount of static friction. Applied force is just about equal to the limiting friction, that is the object is just about to move. Under such condition, we can always find the resultant between the normal reaction and the frictional force, right? By drawing this diagonal. Let's call this, give this point certain names. This is O. Let's call this point B. This is A and this is C. So from the diagram, it is very clear that vector OC is equal to vector OB plus vector OA. Parallelogram law. Let's say this angle subtended by the resultant with the normal reaction. Let's call this angle be theta. Okay. So OC is equal to actually vector R plus Fs max vector, because friction is a force, so it will also be a vector. Now if you look at the diagram, then we can clearly say that tan theta is equal to perpendicular, that is CB by OR, that is CB equal to OA by OR. That is to say, tan theta equals to CB is Fs max by R. Clear? This angle theta is the angle that is made by the resultant of force of limiting friction and the normal reaction with the normal reaction force, that is with the vertical, is known as angle of friction. And this angle of friction, if you remember, we found that Fs max was equal to mu s into R, which gives us Fs max by R equal to mu s, that is coefficient of static friction. So tangent of the angles formed or subtended by the resultant with the normal reaction, resultant of frictional force and maximum frictional force or limiting friction and normal reaction with the normal reaction will be equal to coefficient of static friction. Okay, now friction resists any relative motion between the surface and the object, right? Now, what if we put the object in an inclined plane or in a plane and then start inclining the plane or start increasing this angle phi? Initially, the object will not move or slide down the surface. However, as we keep on increasing the angle, what will happen? We will reach at a point where the object will start sliding, right? Horizontally it was, so the object was not moving, and then we started in the inclination, and after a certain point started moving. So the same case will happen, and we consider the angle phi such that the object just starts moving. So it is the case of a limiting frictional force, that the applied force has become equal to the limiting friction, so that the object will just start moving from this particular point onwards. Now if we consider the various forces acting on the object or on the body, there will always be this weight that will be acting downwards, vertically downwards, right? Now due to the contact, there will always be a reaction force perpendicular to the surface. That will be somewhere along this line. Along the interface, there will always be this Fs max, maximum amount of limiting friction, or the limiting friction, maximum static friction. So these are the three different forces that are acting: weight, the reaction force, and the frictional force. Now, just before the object starts moving, the object is in equilibrium. So these forces are in equilibrium. Now, to find the equilibrium of, or find the equilibrium state of this, what we need to find is that, what we need to note is that the forces directions are different. However, what we can do is that we can always resolve this mg horizontally or along the plane and perpendicular to the plane. That is to say, we can always take a component of this in this direction and in this direction, right? Now, since this angle will, by geometry, be equal to phi, so this component will be equal to mg sin phi, and this component will be mg cos phi. Now it has become easy for us to find the equations of motion. If we consider the equations of motion along the plane and perpendicular to the plane. Along the plane, what we find, there is a net downward force mg sin theta. Sin phi. And then there is a frictional force opposing it along the plane. So, since the object is in equilibrium, so this must be equal to the limiting friction. Perpendicular to the plane, the normal reaction must balance the mg cos phi, or in other words, we can write it for our convenience that the weight is balanced by the normal reaction. So if I take ratio of 1 and 2, that is, if I divide first equation by second equation, we get, therefore, let's call this 1, this 2, 1 divided by 2, equation number 1 divided by 2 will give us 10 phi. Mg will cancel, sin phi by cos phi is tan phi is Fs max divided by R. But Fs max by R is mu s, as we had found. So this is equal to mu s. But mu s was equal to tan theta. So this angle at which the object of the incline at which the object will just start moving or is on the verge of movement is equal to the angle of friction. This particular angle of inclination is known as angle of repose. Okay, so angle of repose is equal to angle of friction for the given pair of surfaces. You need to remember that. Okay, up till now we have discussed about, when we talked about kinetic friction, we have spoken about when an object slides over another. Okay, say we had a plane and an object was there and it was pulled or pushed, and so it started moving in this direction, say velocity u, and so a friction known as kinetic friction was developed, and that opposed the relative motion between the layers. However, if you consider kinetic friction, it actually has two different components, or in other words, there are two types of kinetic friction. One is known as the sliding friction, as we have discussed already, when an object slides over another. The other one is known as the rolling friction. When an object rolls over a surface, say for example a wheel rolls over, the car wheels, what they do, they roll over the road. They do not slide. So under such condition, the friction that is generated will be known as rolling friction, and the force is the force of rolling friction. It's called as Fr. Now it has been observed that the force of rolling friction is always much smaller than the force of kinetic friction, that is force of sliding friction. Why it is so? Now first and foremost we need to understand is that when an object rolls over another, what happens is that at the point of contact, this point, which is very small, and here what happens that the object is momentarily stationary, or the object that is rolling, the wheel say, whenever it's in contact with the surface, it doesn't slide neither forward nor backwards, and thereby reducing the amount of force that is required to overcome this or keep the object rolling. And that is why force of rolling friction is much less than force of kinetic friction or force of sliding friction. Okay, now if we consider or discuss about rolling friction, then we have seen that properties of rolling friction will give us the force of rolling friction is proportional to the normal reaction, as was the case with the sliding friction, or as was the case with static friction also. It's always proportional to this. Further, we have noticed that it is also proportional to 1 by r, that is, it is inversely proportional to the radius of the wheel that is rolling over it, which is very important, which means that if r is smaller, Fr will be larger. If r is greater, Fr will be smaller, that is, the frictional resistance to rolling will be less. Now, from this we can write the force of rolling friction equals some constant of proportionality, let's call this mu r, coefficient of rolling friction, into r, capital R, that is normal reaction, divided by the radius. Now, if you look into this equation, what you see is that the dimension of the unit dimension of the left hand side is of that of force. The dimension of the right hand side also has to be of that of force. But at the same time, what you notice is that this is force. Normal reaction is a force, and this is length. So this whole term, r by normal reaction by the radius, has a dimension of force per unit length, which means mu r now in case of rolling friction is not a dimensionless constant but has a dimension which is that of length. This is how it is different from coefficient of rolling friction is different from coefficient of sliding friction or coefficient of static friction, as we had found earlier. Now this unit of this, SI unit of this will clearly be meter. Okay, now we know that it has been said that wheel is one of the greatest invention of all time. Why it is so? Because of the invention of wheel that rolls over a surface, people used to slide objects over other surfaces to take it from one point to another, which made it the force of friction much larger to carry the same weight or same mass. However, since the coefficient or the force of rolling friction is much smaller than force of kinetic friction, when we roll, we need to apply much less effort. We lose much less energy, and that is why wheel is known as one of the greatest invention of all time, because it reduced our efforts and it increased the efficiency. All right, let's consider a couple of examples now. First, let us say that there is a block of certain mass, say m or whatever, was initially sliding over a surface which has a coefficient, okay, and the mass and the surface, the coefficient of friction between them is given by 0.5. Okay, coefficient of sliding friction or coefficient of kinetic friction. The object was moving with an initial speed or velocity of u equal to 72 km per hour. How far this object is going to move before it comes to rest? That is v equals to 0. From here to here, what is the distance traveled? Let's call this s. So our problem is that our object was sliding with an initial velocity or speed of 72 km per hour over a surface. The coefficient of friction between the object and the surface is mu, given by 0.25. The value is 0.25. How far the object will come before it comes to, or how far the object will move before it comes to rest? Okay, to do this, first of all, what we need to find is that to find the distance from equations of kinematics, we know that we have two equations. One is that v square minus u square equal to 2 as, and s equals to ut plus half a t square. Now, from the information that is available here, it's very difficult for us to find time. So, we also have noticed that we are given the initial speed or initial velocity, which will be useful in both cases. However, in this equation, if we use this equation, we have one variable less, that is, we do not need time, or we do not need to get into the complication of finding the time taken to stop the object. So, if we want to use this particular equation, v square equal to u square minus 2as, then we know that v is given, which is 0 because the object will come to rest finally. U is given 72 km per hour, which is equal to 72,000 meter by 3600 second. 1 hour is 3600 seconds, which will be 20 meter per second. Initial velocity is 20 meter per second. We already have that. Now, if we can find acceleration a, then we can use this equation to find the solution to the problem. Now, to find the acceleration, what we need to observe is that coefficient of friction mu is given, right? So, can we use the equation for coefficient of friction? Well, what we know is that coefficient of friction is given by the frictional force by the normal reaction. Okay. Now, if you consider this problem, what happens is that there is this frictional force acting in the opposite direction to the direction of motion. There is no other force that is acting on it. So, it is the sole force that is producing the acceleration of the object or the negative acceleration of the object in this direction. The object is moving in this direction, the acceleration will be in the opposite direction. However, if you consider the magnitude, then we know that this acceleration is produced only by this force of friction. So, by applying Newton's second law, we can clearly find that this force of friction will be equal to mass of the object multiplied by the acceleration it produces. And the normal reaction, as we know, is given by, is always balanced. If it is the normal reaction R, then it always balances the downward weight. So, it will be mg, which means that A will be equal to mu into g. This will give us, mu has been given to be equal to 0.5, right? And g, let's take for simplicity, g equals to 10 meter per second square. Though we know that it's 9.8, but for simplicity we are taking it as 10 meter per second square. So we get 5 meter per second square. However, this acceleration is in the backward direction. Okay. Now we are in a position, because we know V, we know U, we know A. So if we apply V, U and A, substitute the values of this in this particular equation, V square minus U square equal to 2AS, we will get V square is 0 minus U square is 20 square must be equal to 2. Now this acceleration is a negative acceleration because the object was moving in this direction, the object acceleration is in backward direction, so this will be minus 5 and then S, which will mean that 10 into S equal to 400. That is to say, S, the distance the object will travel before coming to rest, will be given by 40 meter, and this is going to be our final result. Now let's consider another case. We have been given that a bullet of mass 0.01 kg, 0.01 kg is moving towards a block, and it hits the block with that some velocity v, and gets embedded to the block. The block has a mass of mass equals to 4 kg. The whole system moves for 20 meter before coming to rest. We have to find, coefficient of kinetic friction is given to be equal to 0.25. 25. We have to find the velocity with which the bullet hit the block.